Right, another modelling with first order differential equations question. Question number 5. The rate at which a body loses speed at any given instant as it travels through a resistive medium is given by kV meters per second squared, where v is the speed of the body at that instant and k is a positive constant. If its initial speed is u meters per second, show that the time taken for the body to decrease its speed to a half u meters per second is 1 over k ln 2 seconds. So let's have a look at how this question can be done. So in this case, I'm going to denote, so it's already been given, so v is the speed of the body. So v is the speed of the body, and going back to the question, it says that the rate at which a body loses speed, so loses, so this word means a decrease, okay? So in other words, we should have a minus somewhere when it comes to creating our differential equation, so bear that in mind. But going back to this term, the rate means the rate with respect to time, so it's dv over dt in relation to this problem. And since it's losing, so since we see the word losers or loss, let's incorporate a minus here, and that is given by kv, so minus kv. So this is our differential equation. However, let's solve this differential equation. So this is a first order differential equation, and to solve first order differential equations we need to use the method of separating the variables. So next step, so by separating variables, so let me bring this v in particular to the left to give me 1 over v dv, and keeping the minus k on the right, let me bring the, let me amend this, let me bring the dt to the right, so minus k d small t. Now after separating the variables, let's integrate both sides. So let's integrate, so let me write down that step, so integrate both sides. So that meaning we need to integrate the left hand side 1 over v with respect to v. We need to integrate minus k on the right with respect to t. When I integrate 1 over v, so we should have ln v. As for the right hand side, when we integrate minus k with respect to t, we're going to get minus kt plus c, as we're integrating an indefinite integral, so be sure to add an integration constant. So this c is our integration, so let me make a note over here, so it's an integration constant. Now moving on from there, let me rearrange for v. So v would be e to the minus kt plus c. And let me go one more stage, so let me go one stage further. Let me rewrite this as e to the minus kt times e to the c. So we can do this using the multiplication law for indices. So remember the law for indices, the multiplication law. Whenever we multiply two terms having the same base, we add powers. So this step can be done. And if I go one stage beyond, since c is a constant, e to the c is a constant. So if I take a different coloured pen, let me take a red pen. So since c is a constant, e to the c is a constant. So if I replace e to the c by another letter, by d for example, so where d is a constant, so if I let d be e to the c, we can rewrite this equation here. So we can rewrite this equation as v is equal to d e to the minus kt. So to go to this stage here, I've simply replaced e to the c, which is a constant, by another constant, capital D. Now, this is the equation that we have for the moment, but if we go back to our question, it did say that if its initial speed is u. So let me concentrate on that part of the sentence. Initial means the speed at time t equals 0. So at time t equals 0, the speed of this body v is u. So let me take this data and plug it into our solution as it stands in order to calculate an unknown. So if I take the data t equals 0, v equals u. So if we go back to our solution here, so t equals 0, v equals u, and if we plug that into this equation, we're therefore going to get v, which is u, that is d e to the minus k, and small t, which is 0. Minus k into 0 is 0, and e to the 0, so this term is 1. So when you rearrange, d times 1 is d, and d is equal to u on the other side. So that is the value of capital D. However, let me take this purple pen and let me replace d into the previous equation. So if I replace d, this is what we're going to have. We're going to get v is equal to d is u, so it's u e to the minus kt. So this is what we have for v for the moment, but let's go back to this question. Let's see what we need to calculate. So going back to this question, we need to show that the time, so we need to show that t, the time taken for the body to decrease its speed to a half u, is 1 over k ln 2 seconds. So we need to show that t is 1 over k ln 2 when the speed of the body is decreased to a half u. So in other words, let's work out the time and prove that the time is this when v is half u. So let's work out and prove this time. So when v is half u, if we go back to this equation here, so let me just say that when v is half u, if I substitute v by half u, we're going to get half u, and that is equal to u e to the minus kt on the right. Now from this step I can cancel the u's on either side, so we're going to have e to the minus kt, and that is equal to half. Now what I'm going to do in the next step is e to the minus kt, I can rewrite that as 1 over e to the kt, and that is equal to half. And if I go one further stage, when I rearrange, e to the kt should be 2. And so we have e to the kt, which is 2. Let me continue over here. Here we go. So that I can see this solution. If I take ln's on both sides of this equation, I'll have ln e to the kt, and that is equal to ln 2. And if I apply the power rule of logarithms, so if I take this power to the front, we're going to get kt ln e, which is ln 2 on the right. Now ln e should be 1, so that's a standard result, and bearing in mind that ln e is 1, we're going to have kt, which is ln 2, so t is 1 over k ln 2. So this is what we need to prove So this is what's required, because if we revisit the question, we need to prove that the time is 1 over k ln 2. So going back to the question, that is exactly what we have over here, 1 over k ln 2. That corresponds to our solution for t. So that corresponds to the solution that we're looking for question number 5. So that completes this question. So I hope you enjoyed this video. If you did enjoy the video, if you found this video helpful, be sure to subscribe, and I hope to see you again. Thank you.